Okay, so we're doing some work with the distance formula. And a distance formula involves square roots. Okay, so this is the time of year where I usually have to go back and do a little bit of reviewing on simplest radical form. Okay, and simplest radical form has to do with the perfect square numbers. Okay, so how do you generate perfect square numbers? Well, you take all the positive integers and you square them. So you go 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. And so this is how you generate perfect square numbers. Okay, so we've got our 1, we've got our 4, we've got our 9, we've got our 16, 25, then you go 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and then you really should know up to 225. So 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared, it's either 192 or 196. I always forget that one. So let's see, 14 squared, 196. I always forget that one. And then 15 squared is 225. You really should know these off the top of your head. 225, not 222. And so you've got to memorize them. It's that simple. Okay? If you don't know them off the top of your head, then you're going to continue to struggle with simplest radical form. Okay? So when we get to square roots, okay, we have our radical sign, which obviously all you guys have always seen. Okay, and then whatever's underneath the radical sign is called the radicand. Okay, now that's important because I use that word on a regular basis, so you need to know what I'm referring to when I say the radicand. Okay, now to get this guy in simplest radical form, okay, that means that the radicand has no factors that are perfect square numbers other than 1. Okay, it's always going to have a factor of 1, but there will be no other factors that are perfect square numbers, and that's why having the ability to identify, okay, perfect square numbers is really important to doing simplest radical form. Okay, all right, so just make a little note. Remember our perfect square numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. You need to know those off the top of your head, so start working on them. Okay, so we take radical 12, okay, pretty small number, and we say, what's the largest factor of 12 that's a perfect square? That would be 4, okay? So the square root of 12 would be the same as the square root of 4 times 3. And so we can take the square root of 4, that's 2, and we're left with the square root of 3. Okay, so radical 12 in simplest radical form is 2 radical 3. Okay, now we go 24. Okay, so what's the largest factor of 24 that's a perfect square? Once again, it's 4. Okay, that would be 4 times 6. So we can take the square root of 4, which is 2, that goes out front, and the square root of 6 is the square root of 6. Okay, the only factors of 6 are 2 and 3, and they're not perfect squares, so we can't do anything else with it. Okay, we look here. 40. What's the largest factor of 40 that's a perfect square? Again, just like the previous two, it's 4. 40 is 4 times 10. So the square root of 4 is 2, so that goes out front. And we're left with the square root of 10. And the only factors of 10 are 2 and 5, and neither of them are perfect squares, so that's simplest radical form. Okay, square root of 45. The largest factor of 45 that's a perfect square is 9. Okay, that's 9 times 5. Okay, so the square root of 9 is 3. And you're left with the square root of 5 underneath. And 5 is not a perfect square, so there's nothing we can do with it. Okay, 300. Well, it ends in 2 zeros, so 100 has to be a factor of 300, and 100 is a perfect square number. So we get the square root of 100 times 3, and the square root of 100 is 10, and the 3 stays underneath, so we get 10 radical 3. Okay, let's see, 72. Common mistake, people will go 9 times 8 because 9 is a perfect square. But 72 has a larger number that's a factor, and it's 16, okay? At least I think so. Wait a minute, 16, maybe it is. 9 times 8, 9 times, no, 36, I take that back, 36, okay, is half of 72. Okay, so 72 is 36 times 2. Okay, and 36 is a perfect square number, so the square root of 36 is 6, and you're left with the square root of 2, and there's nothing we can do with the square root of 2. Okay, now you come to 90. Okay, well that's 9 times 10, and 9 is a perfect square. So we'd have the square root of 9 times 10. So the square root of 9 is 3, and you're left with the square root of 10. And the only factors of 10 are 2 and 5, and neither of them are perfect squares, so we're done. Okay. Square root of 20. The largest factor of 20 that's a perfect square is 4. That's 4 times 5. Okay, so the square root of 4 is 2, and you're left with the 5 underneath the radical, and 5 is a prime number, so square root of 5 is the square root of 5. Okay, 125. See how the number ends in 25? That means 25 is a factor of it. Okay, so 125 is 25 times 5. Okay, so the square root of 25 is 5, and we're left with a factor of 5 underneath. And just like the guy up above, 5 is a prime number, so the square root of 5 is the square root of 5. Okay, now notice this guy is real similar to the square root of 300. It ends in 2 zeros, so 100 has to be a factor. So 500 is 100 times 5. So the square root of 100 is 10. And you're left with radical 5. And just like the two previous ones, you can't do anything with a square root of 5. Okay. 80. Now, a lot of people would say, well, 4 is a factor, and it is. Okay, but there's a larger number that's a factor. 16 is a factor of 80. Okay, 80 is 16 times 5. So the square root of 16 is 4, and you're left with the square root of 5, and there's nothing I can do with radical 5, because just like the ones up above, 5 is a prime number, so the square root of 5 is the square root of 5. All right, now, 288. Okay, I know 4 is a factor. Okay, 16 might be a factor. 36 might be a factor. So there's some other guys. 64 might be a factor. But here's the largest one. 288, half of 288 is 144. So 288 is 144 times 2. And the square root of 144 is 12. Okay, and then you can't do anything with the square root of 2. Okay, so we get 12 radical 2 when it's in simplest radical form. All right, 99. 9 is a factor of 99. It is 9 times 11. And the square root of 9 is 3. And you can't do anything with the square root of 11 because it's a prime number, just like up here we're like the 5's prime number. And obviously the 2 is as well. Okay, so 11's not a perfect square number. Okay, so let's see. 450. Well, I know 25 is a factor of 450 because the last two numbers, 50, are divisible by 25. Let's see if that's the largest one. 450 divided by 25. It's 25 times 18. Okay, so I have another factor in there. Okay, let me see. 25 times 9. Oh, I think 225. Yeah, what do you know? Half of 450 is 225, so 450 is 225 times 2. And the square root of 225 is 15. And then we're left with the square root of 2, and there's nothing we can do with the square root of 2. Okay, so let's see, this guy, 112, I think it's 16, divided by 16. That is 16 times 7. Okay, so 112 is 16 times 7. I can take the square root of 16, that's 4, and I'm left with the square root of 7. Okay, so we're going to be dealing with radicals, okay, with all of these distance formulas, okay? And I'll show you one, and then we'll wrap this video up, and I'll make a second video for the last couple. Okay, so we're trying to find the distance, okay, from point A to point B. And so when you're talking about distance from A to B, okay, we represent that by just saying AB. It's the length of segment AB. That's the same as saying the distance from A to B. So that's how we represent distance or length, okay? All right, so AB, okay, it would be the square root of, okay, delta x, which is the distance from the x-coordinate to the x-coordinate, delta x squared plus delta y, which would be the distance from the y-coordinate to the y-coordinate, so delta y squared, okay? And so remember, delta means change, and change is subtraction, okay? So what that means, delta x means the distance from one to the other, one x-coordinate to the other x-coordinate, so we just subtract them, okay? All right, so let's see what we got. So I can go -10 minus a -1, or I can go -1 minus a -10. It makes no difference because I have to square the answer. Okay, so I'm going to go -10 minus -1. And then don't forget you got to square that. Plus delta y, which would be the difference between the y coordinates. So I could go 4 minus a -3, or I could go -3 minus 4. It makes no difference because I'm going to square it. 4 minus a -3, like that. Okay, so we simplify. So I get the square root of, see, -10 minus a -1, those cancel each other out, becomes plus, so -10 plus 1 is -9. Again, these guys cancel each other off, so you get 4 plus 3 or 7. And then we have the square root of -9 squared is 81. 7 squared is 49. So I get the square root of 130. Okay? And so we take a look at, is that in simplest radical form? Well, 130 certainly isn't a prime number. Okay, so if I look at the factors, okay, of 130, okay, it's going to be 1 times 130, which doesn't help. It's going to be 2 times 65. 3 is not a factor. 4 is not a factor. 5 is a factor. Let's see, 5 times what? 130 divided by 5. That'd be 5 times 26. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. I think it's just going to be the 10 and the 13 now. Okay, so if you look at all of those, the only guy that's a perfect square is 1. So the only factor of 130 that's a perfect square is 1. So by definition, that's in simplest radical form. And there's your distance from A to B. It's radical 130. Okay, we'll come back on the third video and do some more of those.